February 8th through the 12th, we're going to be looking at lesson 23, comparing rational expressions. Really quickly, I just want to look through the opening exercise. I want to talk about which fraction is bigger. Is 1/3 bigger than 3/8, or is 3/8 bigger than 1/3? All right. We are going to be comparing rational expressions. So our whole goal is to compare rational expressions by writing them in different but equivalent forms. So in looking at this, there are a couple ways that I can actually talk about this fraction, these two fractions. All right. One of the biggest things would be to create an area model. So I'm going to create an area model here. All right, and I'm going to represent the fraction 1/3 here. And then I'm going to create an area model here. And notice that my area models are the same size. And I'm going to break this one down into eighths. Okay. Now, actually that didn't work out quite as well as I wanted it to. If I were looking at 1/3, and let me see if I can do this a little bit better. 1, 2, 3, 4, 5, 6, 7. And then looking at 3/8, I would see that 3/8 is just a little tiny bit bigger than 1/3. All right, now the key to this, the only bad thing about this is you have to make sure your area model is divided equivalently. All right. So what's another way that I could discuss 1/3 and 3/8, figuring out how or which one? Is there a better way instead of drawing an area model? You actually can do decimal equivalents. All right, so in order to find the decimal for 1/3, I would divide 1 by 3, and that gives me approximately 0.3333, and that 3 actually repeats. All right, so then to find the decimal equivalent of 3/8, divide 3 by 8, and you get 375 thousandths. All right, so I can actually see that 3/8 is still just a little bit bigger than 1/3. Another way that I can do this is I can do common denominators. In this case, 24 would be a common denominator. 3 goes into 24 8 times, so 8 times 1 is 8. 8 goes into 24 3 times. 3 times 3 is 9. Once again, I can see that 3/8 is just that little tiny bit bigger. All right, so 3 different ways that I can figure out those, which one is bigger. All right, so we're going to start by working with positive integers. We're going to let m and n be positive integers. Work through the following exercise with a partner. Well, you don't have a partner, you've got me. All right, so it says fill in the following table. This is my value for n, and they said put 1 over n. So we'll put 1 over 1, which is 1. This will be 1/2, 1/3, 1/4, 1/5, and 1/6. Not that difficult. Okay. Do you expect 1/n to be bigger or smaller than 1 over n plus 1? And do you expect 1 over n to be bigger or smaller than 1 over n plus 2? Explain why. Well, let's look at this. As my number increases, what happens to my fraction? my value of my fraction decreases. So I've got 1 over 1. When n was 1, I had a whole. But when it increased for the value of n, my fraction went to 1/2, which is smaller than 1. So from the table, as n increases, one over n decreases. Okay? So then let's think about this. Do I expect 1 over n to be bigger or smaller than 1 over n plus 1? So if I add 1 to n, then I'm going to end up getting a smaller number. So I would think that it's going to be smaller. So 1 over n will be smaller than 1 over n plus 1, and smaller than 1 over n plus 2. All right? Because it's getting smaller as my values increase. As my values for n increase, my value of my fraction decreases. Compare the rational expression 1 over n plus 1, and 1 over n plus 2 for n is equal to 1, 2, and 3. Do your results support your conjecture from exercise 2? Revise your conjecture if necessary. Okay. So, let's think about this for just a second. So if n equals 1, this is what I got. So I get 1 over 1, which is 1. I get 1 over 1 plus 1, which is 1/2. Okay. And then 1 over n plus 2 would equal 1/3. So 1 is greater than 1/2, which is also greater than 1/3. So it worked for this. Let's see if it works for n equals 2. All right, so 1 over n would give me 1/2. 1 over n plus 1 would give me 1/3. And 1 over n plus 2 would give me 1/4. So 1/2 is greater than 1/3, which is greater than 1/4. All right? And then for n is equal to 3, 1 over n is equal to 1/3. 1 over n plus 1 is equal to 1/4. And 1 over n plus 2 is equal to 1/5. 1/3 is greater than 1/4 is greater than 1/5. Now, how can I know that for sure? Well, I can get a common denominator for 3, 4, and 5. So 3, 6, 9, 12 would work for part of it, but not all of it. 15 would not work for all of it. 18 would not work for all of it. 21, 30 won't work. So it's kind of hard for this, so we would probably have to use 60. 3 goes into 60 20 times, so 20 times 1 is 20. 4 goes into 60 15 times, and 5 goes into 60 12 times. So I can see that this works. So my conjecture is true with number 2. homework in exercise 1 and 2, generalize how 1 over n compares to 1 over n plus m, where m and n are positive integers. Alright, so since m is a positive integer being added to n, then I know that my denominator is going to increase. So since m is a positive integer being added to n, my denominator will increase. Okay? My denominator is going to increase. As my denominator increases, the value of my fraction will decrease. As the denominator increases, the value of my fraction decreases. Okay, the value of my fraction decreases. Alright, so that tells me that 1 over n is going to be greater than 1 over n plus m. Will your conjecture change or stay the same if the numerator is 2 instead of 1? Make a conjecture about what happens when the numerator is held constant, but the denominator increases for positive numbers. Okay? So, will your conjecture stay the same if the numerator is 2? Alright, so let's think about this. Let's just kind of look at it for a second. If I have 2 over n, alright, so we can kind of just make a table really quickly of what will happen. So 2 over 1 would be 2. 2 over 2 would be 1. 2 over 3 would be 2/3. 2 over 4 is 1/2. 2 over 5 is 2/5. 2 over 6 is 1/3. Notice what happens. My value still decreases. So it will stay the same because this would be the same as multiplying the inequality by 2. Alright? So our conjecture will stay the same. Alright? Because I am, it's just like multiplying the whole entire thing by 2. Alright? So if my numerator stays constant, then my denominator is going to increase. So therefore I have a smaller value. Alright, so suppose we want to compare the values over the rational expression. Let me find my paper. Suppose I want to do x plus 1 over x and x plus 2 over x plus 1. Suppose I want to compare the values of this rational expression for positive values of x. What are some ways to do this? So how might I do this? You could do a table. You can find a common denominator. You can cross multiply. You can do a lot of different things. Alright, so I think the best thing would be to start with a table. Alright, so we're going to plug in values here. Alright, now you probably will need a calculator for this because they can get a little crazy. So we're going to do 0.5 plus 1 divided by 0.5. All right. So 1.5 divided by 0.5 gives me 3. All right. So 1 plus 1 is 2. Divided by 1 is 2. All right. We're going to do 1 plus 1.5. And then we're going to divide that by 1.5. Notice that gives me a repeating decimal. So we're going to say that it's 1.667. Okay, so 2 plus 1 is 3 divided by 2 is 2/3. I'm sorry. Is 3 halves, which is the same thing as 1 1/2. All right. So we have 5 plus 1 divided by 5 gives me 1 2/10. So I have 10 plus 1 divided by 10 gives me 1 1/10. All right. And then 100 plus 1 divided by 100 gives me 1 1/100. All right. So I went ahead and did it in decimal form because I think they're easier to compare. All right, let's do our x plus 2 over x plus 1. So I have 0.5 plus 2 divided by 1.5. That didn't give me the right answer. $1.667. All right. So 3 divided by 2 is 1 1/2. All right, 1 1/2. So I have 3 1/2 divided by 2 1/2 gives me 1 4/10. All right, so I have 4 divided by 3, 1.333. I have 7 divided by 6, 1.167. All right, notice that the 6 is the only thing that repeats. All right, so I have 10, so 12 divided by 11. Ooh, look at this, 1.090909, so the 09 repeats. All right, and then I have 102 divided by 101, 1.0099. Okay, so let's look at this. What did we realize? We realized that it holds true here also. Look at this. My values are decreasing in my tables. It appears, if I just look at this, if I were comparing these, it appears that x plus 1 over x is greater than x plus 2 over x plus 1. Now, here's the thing. We have only checked 7 points. So we cannot yet say this is the case for every positive value. So how else could we compare these two expressions? We could actually graph them. All right? If I graph them, so let's graph them and see what this would look like. Let me get my graphing calculator to turn on. Remember, you can always use Desmos.com to graph, or if you download one to your phone or your computer. All right, so we're going to graph x plus 1 divided by x. All right. And then we're going to graph x plus 2 divided by x plus 1. And then I'm going to zoom in on my window. Well, maybe. It wants to be a pain. And I would love to be able just to grab it and okay, for some reason it shows that my graphs have disappeared. Don't really know why. I love technology. There we go. Okay, so when I graph these, I want you to see. The blue graph, this graph right here, is my x plus 1 over x. My red graph, this one here, the outer one, is the x plus 2 over x plus 1. Okay? Does it verify the fact that this one looks like x plus 1 over x is greater? Well, if you look at this, look at what happens as they get closer. They're starting to get closer and closer together. So, what will I need to do in order to compare these? If I actually want to compare these, what would I do? Because I cannot say that x plus 1 over x is greater than x plus 2 over x plus 1. Because my graph even shows that they get very, very close. And they may eventually overlap. I don't know. So what did we do before comparing our 3/8 and our 3/8 and 1/3? We had to find a common denominator. Alright, so am I going to have to find a common denominator here? No. Here's the nice thing about this. Well, you can say we have to find a common denominator. But let me show you what we can do. So I want to compare x plus 1 over x and x plus 2 over x plus 1. Alright? I can set these equal to each other. Alright? So I'm going to set these equal to each other. And then I need to do some multiplication. Alright? So, I need to find common denominator. So my common denominator would actually be x times x plus 1. But I can do cross multiplication. Okay? So x times x is x squared. And x times 2x is 2x. Now, the only thing is you've got to be really, really careful about how you look at this, because if you do the cross multiplication, you've got to remember that now this is what this is. So this is the same as x plus 2 over x plus 1. Okay? And then let's look at this. So I got to do x plus 1 times x plus 1. So x times x is x squared. X times 1 is 1x. X times 1 is 1x. And x times 1, or 1 times 1 is 1. So I get x squared plus 2x plus 1. and that is my x plus 1 over x. Alright, so looking at this, I can clearly see, okay, they both have x squared, they both have a 2x, but this one has 1 more. So I can clearly see that x plus 1 over x is greater than x plus 2 over x plus 1. Alright? Alright, so I can do this for I can compare these this way. Alright, so really quickly, let's just kind of do comparison. Rational numbers, I can visually, like rational numbers, that would be our fractions that we did at the beginning, our 1/3 and 3/8. I can visually see that. I can use area models or number lines to compare those. Numerically, I can find common denominators and look at that. Rational expressions, these right here, I cannot just look at a table and see because I don't look at all the positive numbers. So I would have to graph them to see. I can compare several values, but like I said, that doesn't tell me everything. Alright, and then algebraically, I can find common denominators, and I can solve it algebraically like this. Alright, so how do we compare rational expressions? We can use a graphing calculator. We can do things like this algebraically. Alright guys, have a great rest of the week.